Today we're going to start talking about sinusoidal models. So first we're going to talk about the angle movement of a circle. And this is just the unit circle with a radius of 1 centered at the origin. Now, if you can't remember all of those special unique angle properties, what the x value, the y value are, you can always set up a right triangle and use SOHCAHTOA to help you out. So, finding the exact values of the following expressions. We know sine pi over 4. Pi over 4 is the same as 45 degrees. And sine means what is that y value. So, if you remember that rule off the top of your head, it would be the square root of 2 over 2. If you are unsure, what you can do is that triangle we have up there where you have y. You're going to keep that, ignore the x. The angle you're going to put in, you can either put pi over 4 or you can put 45, but make sure whichever one you use, you have that option selected in your calculator. So your calculator is in radians if you put pi over 4. Your calculator is in degrees if you put 45. And so then you would have sine of pi over 4 equals y over 1. And then calculate for y if you can't remember the rule that it is just pi over 4. Or you can use your special right triangle 45, 45, 90 rules. Then cosine of 60, it is the same as pi over 3. And then again, cosine means find the x value. So same thing. This is 60, so you can use your 30, 60, 90 rules, or use that triangle. This time you can put in 60. Make sure you're in degrees. Ignore that y value. So it would be cosine of 60 equals x over 1. Calculate it, and you should get 1/2. So trig identities. That first one I know for sure is in the folder. I think the others are, but don't hold me 100% to it, but I'm pretty sure they are as well. Now, another one that you need to know is cosine of 2 theta equals cosine squared theta minus sine squared theta. The reason why is we will be using this in class, so you'll want to know that one, and it's not in the folder. So, trig graph properties. Your periodic is just a graph that repeats itself continuously. So our sinusoidal functions are going to be periodic functions. They're constantly going to continue in the same manner. And then your principal axis is the axis that the function oscillates on either side of. So pretty much it's where that even fold is. So then your period is the distance, the horizontal distance between a point and the corresponding point. So usually what you do is you look at those maximums and where your first max is to your next max is your period. And the parent function of y equals sine x, your period is 2 pi or 360, however it's going to be used. You'll see that IB is going to use both radians and degrees, so be used to both. Amplitude is the vertical distance from the principal axis to either the max or the min. Most people usually look at it from the principal to the max. And again, your principal axis won't always be at the x-axis. It could move up or down. So, thinking about transformations, this looks very similar to a quadratic transformation. It's just you now have a trig function. So the magnitude of A, or in this case, sorry, not the magnitude, the absolute value of A is your amplitude. Your amplitude is always going to be a positive number, so it doesn't matter if A is negative. And then A itself is also a vertical stretch. B is your horizontal stretch with a scale factor of 1 over B. C is your horizontal translation, so you're moving left or right, and D is your vertical translation, so moving up or down. So then how to find the period given an equation, it is 2 pi over B, and that is something you will have to memorize. So finding the period and the amplitude. So here you can see it's oscillating. No, it shouldn't say x equals 2. That should be y equals 2. It's oscillating at y equals 2. That's where you can essentially cut it in half. So from y equals 2 to the max where it's 4, that's a distance of 2. So your amplitude in this case is going to be 2. Now for your period, here, that first max, we don't know that exact number because we're not given the equation and it doesn't fall exactly at pi over 4. Our next max does, but again, we can't find that exact because we can't subtract the 2. So what you can do is you can look, okay, I have 1 cycle, 2 cycles, 3 cycles. So it's going, and your last cycle ended at 2 pi. So 2 pi over 3 will be the period. So then here, finding the transformations, you have a vertical stretch with a scale factor of 3 because that is where the A value is. You're going to move to the right 5 pi over 6 units. And then you have plus 1 at the end, so you're going to move up 1 unit. So again, very similar to transformations of quadratic functions. It's just now you're doing the same with sinusoidal functions. So we're given a few points and we want to find the different values of A, B, C, and D. So your D value is the halfway between your max and your min. And again, it's the Y value. So we're going to add those Y values and divide by 2, and we get D equals -3. So again, A is the distance from, and then so our amplitude is the distance from D to the max or min value. And again, that is the Y value. So in this case, I'm going to take the min value from -8 to -3. That is a distance of 5. Now you could do from -3 to 2. It is still a distance of 5, which is your amplitude. So for B, your period 2 pi over B, this is the length from the first max to the next. So again, it is a periodic function. So it takes the same path each time. So from your max, starting at the x value of 1, the min goes to 5. That is a difference of 5 or 4 units. 4 more units over is that x value is 9. So your second max is going to be at 9. So then from the first to the second, that's a distance of 8. So 8 equals 2 pi over B. B is going to be pi over 4. And then we can plug all of that in and plug in a point. In this case, I chose to plug in the point 1, 2. Simplify, so add the 3 over, then we're going to divide by 5, distribute the pi over 4. And then to get everything inside the parentheses by itself, do inverse of sine. This is in radians, so make sure you're in radians. And then one of the errors I had, it should have been a plus up there, so now you can see I changed those to plus. Subtract your pi over 4 over, subtract it over, then divide by 4, pi over 4, and you get C is 1. So then you can plug everything into your equation.